You ever just stop and think about why you can remember what you had for breakfast yesterday, but you have no idea what you're going to have tomorrow? It's one of those questions that feels so simple, but it's actually one of the biggest mysteries in science. And today, we're going to crack it open. Let's get into it.
I mean, you feel this, right? Every single second, it's like we're on this unstoppable river, just flowing in one direction. It carries us away from a past we know, straight into a future that's a total blank.
But why? Why can't we just, swim upstream? It seems like such a basic question, but it gets right to the core of how our entire universe is built. Why is time a one-way ticket with no return trip? That's the puzzle we're going to solve.
So, to start, you don't need some fancy physics lab to see time's one-way street in action. Nope. The evidence is literally all around us, in the most ordinary things that happen every single day.
Think about it. If you drop a glass and it shatters, that's it. If you saw a video of all those little shards flying back together, jumping off the floor and forming a perfect glass on the table, you'd know immediately, hey, that's being played in reverse. It just feels fundamentally wrong. Things break, they don't unbreak. Or, okay, how about this? You pour a hot cup of coffee, you see the steam rise and just disappear into the air. Can you imagine all those scattered water molecules deciding to have a reunion and dive right back into your mug? No way. These things only happen in one direction. They're like little signposts all pointing the same way down time's highway.
All right, brace yourselves because this is where things get really, really weird. Our everyday life screams that time only moves forward. But the fundamental laws of physics, the actual rulebook for the universe, they don't seem to care which way time is flowing at all.
So if you zoom way, way down to the level of single atoms and particles, nearly everything they do is completely reversible. A movie of two atoms bouncing off each other looks perfectly normal whether you play it forwards or backwards. The math works both ways. But our world, the big world of people and glasses and coffee, completely ignores that. It only plays the movie forward. And that is the paradox. That's the giant puzzle that kept scientists up at night. How do you build a one-way universe using two-way building blocks? The rules just didn't seem to fit the world we were actually living in. But there is an answer, and it comes down to one of the most powerful ideas in all of science. Honestly, this one concept is the key that unlocks the whole mystery of why time has an arrow. And the hero of our story has a name: entropy. All entropy really is a way to measure disorder or randomness. So a perfectly stacked deck of cards has very low entropy. That same deck, after you've shuffled it a bunch of times, that's high entropy. And what's so cool is why things always get more disordered. Look, for that deck of cards to be perfectly ordered, ace, king, queen, all the way down, separated by suit, there's only one way for that to happen. Just one. But how many ways can that deck be shuffled and messy? Billions and billions of ways. It's just a game of probability. And the universe always bets on the most likely outcome, which is always more disorder. This idea is so unbreakable that it's a law of nature. It's called the second law of thermodynamics, and it basically says that for the universe as a whole, the total amount of disorder, the entropy, is always going up. It never goes down. This is the one law with the directions stamped right on it. This is the rule that says, nope, that glass isn't putting itself back together. Okay, so here's the big payoff. We can take this cosmic law and plug it right back into our own experience of time. This isn't just some abstract physics thing. It is the reason we have a past that we can remember and a future that we don't. And this just lays it all out perfectly. The past is, by definition, a time of lower entropy. We know the universe started in a really, really ordered state with the Big Bang. The future, then, has to be a state of higher entropy, more disorder. What we call time is nothing more than the universe taking its natural, inevitable trip from that state of order towards disorder. And this is the engine driving the whole thing. The total disorder in the universe is on a one-way trip. And as you can see from this arrow, it's always, always going up. It can't go down. It can't even stand still. And that relentless climb is what we feel as time moving forward. The arrow of time is the arrow of entropy. They're the same. When you boil it all down, it's such a beautiful and kind of mind-blowing idea. We're not just watching this happen from the sidelines. We are in it. Our bodies, our brains, our memories, we're being carried along this massive cosmic current from a more orderly past to a messier future. So let's just do a quick recap. We feel time as a one-way street, but the laws of physics weirdly work both ways. The solution to that puzzle? Entropy,
which is just a measure of disorder. The universe has a fundamental rule, the second law of thermodynamics, that says total disorder is always increasing. And that constant increase in messiness, that is the arrow of time.
And that leaves us with one last huge thought to chew on. If our universe's story started in this state of super low entropy at the Big Bang, and this arrow of time is carrying us towards a final state of maximum entropy, what does that end state of total, complete disorder even look like? Well, that's a wild question for another day. Thanks for exploring this with me.